section 1.5. That's learning approaches. Instance and model based. All right, section 1.5, learning approaches, instance and model based. So we want to compare and contrast these two different learning styles. First, we'll talk about instance-based learning. And that's pretty simple. In instance-based learning, all we have are a number of classes, right? So we've got class A here, which is blue squares, and class B, which is green triangles. And I've got a lot of B, and I have a lot of A, right? And let's say I've got a new one here, a new instance, right? So I want to figure out, is this class A or class B? In an instance-based approach, all I'm going to do is maybe find my distance to my 3 closest pieces or my 4 closest pieces or whatever is within a radius and say, what am I most like, right? Depending on feature 1 and feature 2. And maybe that's just going to be take a voting poll, right? I'm close to 2 of A and 1 of or 2 of B and 1 of A, so I'm probably going to be a class B, right? If this instance came way out here, I think we'd be pretty good calling it a green triangle. And if the instance came right out here, it would be pretty good calling it a blue square. That makes sense? So an instance-based learning is a pretty straightforward way of just taking the data and comparing what we have. The other way that we can do it is a model-based approach. So 1.5.2 model-based approach. And these are really nice because they're more scalable, right? So instead of saying, hey, here's my new instance, which is still kind of close to class A, I'm going to just draw a model through this, right, using some mathematical tools. And this model, which is represented here by the orange line, is going to separate it, right? So everything over here is going to be A, and everything over here is going to be B. Now, are some things going to be misclassified? Yes, right? There's always some slippage in life, which is depressing, but no model is perfect. But a model approach is nice because it's more actionable, and also a model approach can start to give you some information of what if you have a data point here or here, right? Because while you have information on feature 1, you don't have any information really for that on feature 2, right? If you kind of draw a horizontal line out, there's very little information on feature 2. So you can start to extrapolate past your data a little bit with a model. Always super dangerous. You don't want to go too crazy selecting models that way, but definitely an option. Or selecting or inferring data that way, but selecting an option. So the next thing we want to talk about is selecting ML models or methods. So 1.5.3, selecting ML methods. And for that, there are some wonderful tools that have been created, including this wonderful plot that is in the SciPy the scikit-learn documentation, right? And this is a great way to help you pick a tool. So first you start, right? And then you run down to your numbers of samples. So if you have less than 50 samples, maybe you should get more data. It is kind of hard to do a realistic machine learning project with less than 50 samples, right? Less than 50 samples might be a very good way to learn about the methods and study what's going on. And then do you want to predict the category, right? If yes, then the question is, do you have labeled data? And then if less, the question is kind of how much data do you have? Let's say we have under 100,000. Well, maybe you want to do a linear SVC. Is it text data? No, you could do it K nearest neighbors classifiers. If it's text data, maybe do a naive Bayes. These are all kind of classical machine learning systems. You're not going to see neural networks or anything on here. But when you have a machine learning project, working your way through this flow chart is very useful